Alright, so hello and welcome everyone. We are live right now. So welcome back to this amazing platform of Tutee Learning. And in today's lecture, we're going to discuss about another very important concept that is going to be on the concept of tangents and normal to a parabola, right? So as of the last lecture, we have been discussing with the standard equation of the parabola, and then we understood how to identify or write the general equation of parabola, and from there we discussed about that how can you recognize what kind of conic section is given to you, right? So we have been discussing with those particular stuffs in the previous lectures. Okay, so if you're new to this particular platform, I would request all of you to please go back and watch the previous lectures before you start to watch this continuing lecture, right? So this is going to be lecture number 4, and in today's lecture we're going to discuss about the intersection of a line and a parabola. That is going to be the concepts of tangents and normals, right? So let us start. Now before I start, also one more important thing is that I gave all of you to solve these 5 homework problems in the previous class. Okay, so I am pretty sure that you must have tried to solve these problems and must have got the answer. Okay, so if you have got the answer, you can let me know in the live chat itself, or we can discuss about the solution in some of the later portion. Okay, is this clear to all of you? Is this part clear? So let us start with today's topic, that is going to be the intersection of line a line and a parabola. Okay, intersection of a line and a parabola. Okay, so today we're going to discuss about the intersection or the concept of intersection of a line and a parabola. Okay, to begin with, we shall take the standard equation of the parabola, that is, so let me first of all draw the situation so that you can understand. So this is my coordinate axis. So I'm going to take the standard equation of the parabola, which is going to look like y square equals to 4ax, y square equals to 4ax, right? Now, now there can be certain situations that the line is intersecting the parabola, something like this, where the line is intersecting the parabola at 2 points, where the line is intersecting the parabola only at 1 point, and the line is not at all intersecting, right? So these are the following cases that we can have. All right, now how to understand that which of the following line intersects or do not intersect is basically very simple, is done by solving the line equation in the parabolic equation, and then we look for the solution or the roots of the particular equation, right? So let us say that the line equation be given as y is equal to mx plus c be the equation of the line. Okay, now if I need to solve this first equation with the second equation in order to find for the solution, what we can do is that to get the required equation, that is the line equation and the parabolic equation, what I can do is that I can substitute this value of y in the first equation and I can solve for a quadratic in x, right? So that quadratic will look something like mx plus c whole square is equals to 4ax, right? So then if I keep on solving it further, m square x square plus 2 times of mxc plus c square is equals to 4ax, right? Which I can make it a quadratic, that is m square x square plus 2x times of m into c minus 2 times of a and plus of c square. Now this is going to be the quadratic in x, right? So this is the required quadratic in x. Now this quadratic in x gives two values of x, right, which corresponds to, or the roots of this quadratic equation in x actually corresponds to those particular point of intersection of the line and the parabola, right? So if in this case I have two roots, that is when my discriminant of this particular quadratic is greater than 0, then this line is nothing but a chord. Okay, and in this case if I have only one root, that is it is touching the line is touching the parabola only at one point, then this is the case for the tangent, right? And if it is having no real root, okay, so no real root actually implies that the line is not intersecting. Okay, so this is not of our interest, right? So depending upon the discriminant of this particular quadratic equation, we can determine the cases of chord and the tangent, right? So therefore if I try to find out the determinant over here, the discriminant, sorry, So the discriminant D is going to look like 4 times of MC minus 2 times of A and whole square of it minus 4m square c square, and that I can simplify and I can write it as 4a square minus of 4amc, right? So this is the value that is going to determine that what is the nature of the line in the parabolic intersection. So depending upon whether it is greater than 0, equals to 0 or less than 0, I can determine these 3 different cases. I hope this is clear to all of you. So from here, if I get the relation as A greater than MC, then it is the case of a chord. If A is equals to MC, then it is the case of tangent, and if A is less than MC, then not intersecting, right? So it is not even intersecting this particular case. So no intersection, right? I hope this is clear to all of you. Right. So from here also we can easily find out the slope of the tangent, right? So slope of the tangent in the at a given particular line, for a given particular line from here can be given as A upon C, right? The slope of the tangent from here can be given as A upon C, right? Alright, is this part clear to all of you? Please do let me know in the live chat, is this part clear or not, so that we can proceed forward with our next discussion. Okay. I hope this is clear, right? Okay. Alright, so moving forward, let us discuss about the equation of a tangent to a given parabola at a given point, right? So, and we will try to see that whether this result is satisfied or not, right? So, this was the condition for the intersection of a line and a parabola, where the line equation is given as y equals to mx plus c, and the parabola is a standard parabola, and depending upon that quadratic in x, we can figure out that what is the kind of or the nature of the line we have, right? Now it is our task to basically determine the equation of the tangent, to the parabola. Okay, so now it is our time to determine the equation of a tangent to a given parabola. So let us, for our simplicity, let us take the standard parabola, that is y square equals 4ax, and let us say I want to draw the tangent at a point P on the parabola that is given as x1 y1. Okay, so if I try to draw the situation is something like this. We have the standard parabola, and let us say at this point P, which is coordinates is x1 y1, I want to draw the tangent. Okay, so this is the tangent that I have drawn over here, right? So PT is my tangent, right? Now let us try to apply the differential approach over here that we have learned in our chapters of applications of derivative, right? So if I want to find out the slope of the tangent to any continuous curve, okay, at this point P, which is given by x1 y1, the slope of the tangent at this point is given by differentiating this particular curve with respect to this x and at point P, right? So if I do that, then I will get, so differentiating, so we have the expression y square equals to 4ax. So therefore differentiating this particular expression both the side with respect to x, I will obtain the dy by dx as, so from here we get dy by dx to be coming out as 2a upon y, right? Now we have to put the point P, so it should be y of 1, right? So slope of the tangent at a particular point P is given as this particular form, right? Slope of the tangent at a particular point P is given as 2a upon y1, right? Now from here, if I want to formulate the equation of the tangent, what I will get? So from here I can easily formulate the equation of tangent as the line equation, which is y minus y1 is equals to slope of the tangent, that is given as 2a upon y1 multiplied with x minus x1, right? So this is how we can formulate the equation of tangent over here. Right, now moving further, what we can write, and we can simplify this particular expression, and it will be becoming as y into y1 minus 2 times of x is equals to y1 square minus 2 times of minus 2 times of ax1. Okay, now this particular value on the right hand side is going to be a constant, and we can simplify this constant as follows. So I can write this expression as y1 minus 2 times of ax minus 2 times of ax1. If I do it, then I'm going to get the expression on the right hand side as y1 minus 4 times of ax1, right? So what I'm doing is that I'm subtracting 2ax on both the side, and therefore this expression is going to be equal to 0. And from here I will obtain y1 minus of 2a times of x plus x1 is equals to 0. So this is going to be the general equation of the tangent at any point P, which is x1 y1. Now if you remember that when we were discussing about the equation of tangent in circles, we said that in order to find out the equation of a tangent at a given point x1 y1, what we do? We do it by general transformation, right? So what we do is that we transform x with xx1, x square with xx1, y square with yy1, and x with x plus x1, and y with by 2, and y with y plus y1 by 2, right? So if you remember this transformation, then what you can relate it with is that this particular transformation or the equation of the tangent is nothing but doing the transformation t equals to 0, right? So from the standard equation of the parabola that is given as y square is equal to 4ax, the transformation will look like y1 is equals to 4a times of x plus x1 by 2, right? So if you simplify this expression, you are going to get the similar expression over here, right? I hope this is clear to all of you. So t is an expression which is obtained by replacing the y square with y1 term and the 2x term with x plus x1, right? Is this particular part clear? Is this part clear to all of you? Is this part clear? Any doubts? My inner soul. Okay, great. Is this clear to all of you, right? Now, certain more important thing is to understand over here is that now this particular point is on the parabola is given as x comma x1, right? But instead of having the point on the parabola, I can also write that same point on the parabola in terms of parameter, that is a t1 square comma 2at, right? At square comma 2at, right? So in this way also we can write the any point on a parabola which is called as the parametric form, right? So therefore using this parametric form we can also write the equation of a tangent. So the equation of the tangent in the parametric form would come out as, first of all let me try to see what is the slope of the tangent coming up in the parametric form, right? So slope of the tangent will be 2a upon y1. So y I can put it as y1, I can put it as 2at. So this will come out 2a divided by 2at is going to be simply 1 upon t. So it is very simple to understand the slope of the tangent in parametric form, which turns out to be 1 upon t. So the parameter is t, then the slope of the tangent at a particular point p is given as 1 upon t, right? And in the similar manner we can also formulate the equation of the tangent at this particular point p, which is going to come out as 2a ty is equals to 2a times of x plus at square plus, or we can, so this will be the expression, and we can simplify this expression to get yt is equal to x plus yt equals to x plus at square, right? So this is a simpler expression that you can take care in your mind, right? Now you must be wondering that what happens if we don't have the standard equation of the parabola, right? So in the other equation, if you recall that we described that if the parabola is rotated by 90 degree where it is inclined or it is towards the y-axis instead of the x-axis, or if the axis is replaced by y-axis, then we just need to replace the relation with x with y. That was the only thing that we need to keep in mind, right? So if you take those particular part in your mind, then you will be easily able to solve the problems, right? Is this part clear? Okay, so this is the equation of a tangent in the parametric form, right? Now, in the similar approach, we can also solve this question in the slope format. That is, if I want to write down the equation of a tangent in a slope form. For example, I know the slope of the tangent and I want to write down the equation of the tangent in the slope form, right? So what I can also do is that, so if I want to represent the slope format, okay, so if I want to represent the slope format, the slope of the tangent is actually given as 1 upon t, right? Is 1 upon t. So therefore, what I will have is t as 1 upon m, right? So therefore, I will have t as 1 upon m, and in this manner, I can replace this equation of ty is equal to x plus at square as a y x equals to, sorry, y equals to, so I'm substituting t as 1 upon m, then I can cross multiply with m on the right hand side, so it will become y equals to mx plus a upon m. Okay, so this is called as the general equation of a tangent in the slope format. So this is the equation of the tangent in the slope format. I hope these three formats or the three equation of tangent in different format is clear to all of you, right? So this is how we obtain the required relation. Okay, so now if someone is really curious that what happens that if I transform or if I just shift the vertex of the parabola to different point, like let us say h comma k. Okay, so in this case also, if your parabola is having the standard form like this, that is y minus k whole square is equal to 4ax time minus h, so this particular form, then only thing that may be changed is the transformation of the x and the y. So in this case also, the equation of the tangent, the tangent equation will be y minus k is equals to m times of x minus h plus of a by m, right? So this is how simple the results are, right? So if you, even if you transform the vertex of the parabola to different point, then also the result is going to remain the same as long as you preserve the transformation of the coordinates, right? Is this part clear, right? Now let me do one thing, and you must be also thinking that what about the other standard parabolas or other standard forms of the parabolas when the axis of the parabola is changed, right? So that particular result also I'm trying to put it up over here, so you can take a note of this other forms as well, right? So the only thing that you need to observe is that if the axis of the parabola is shifted, right? So in this case, over here the axis of the parabola is shifted, right? So in this case you will see that the parametric form is also shifted, is also reversed or switched, and also it is just replaced with x with y, right? Over here you can see, right, the equation of tangent becomes now tx equals to y plus at square, right? So this is the only difference that you need to take in mind, right? And also from here you can also find out if you have the slope format, you can also find out the point of contact, right? You can also find out the point of contact. So from the slope format, you can also find out the point of contact, that is, so it was basically at square comma 2at, where t is 1 upon m, that can be given as a upon m square comma 2a upon m, right? So this is going to be the point of contact in terms of slope, right? Is this part clear, right? So I hope this is clear to all of you. So रश्मि पिया, कॉम्प्लेक्स नंबर पढ़ाओ मास्टर. कॉम्प्लेक्स नंबर मैंने ऑलरेडी पढ़ा दिया है, राइट? मैंने ऑलरेडी वन शॉट में पढ़ाया है, और फिर कॉम्प्लेक्स नंबर हम बाकी हम अलजेब्रा के टाइम में डिस्कस करेंगे, ठीक है? कॉम्प्लेक्स नंबर अलजेब्रा के साथ डिस्कस होगा. सबसे पहले कोऑर्डिनेट ज्योमेट्री खत्म करते हैं, फिर हम चालू करते हैं अलजेब्रा के साथ, ठीक है? और अगर आपको कॉम्प्लेक्स नंबर में वन शॉट देखना है तो डेफिनेटली इस चैनल को सब्सक्राइब कर लो, और बहुत जल्दी हम आने वाले हैं उस लेक्चर्स के साथ, ठीक है? इज इट क्लियर रश्मि पिया? Is it clear to all of you? Is this part clear? Okay, so I hope you have taken down these things. Okay, now let us also discuss about another concept that we have already studied in circles, that is the concept of pair of tangent, right? So let us see whether the same relation holds true over here as well or not, right? So let us discuss about pair of tangents. Okay, so let us discuss about pair of tangents, right? So if I say that to a given parabola, and again let us take the standard parabola to for the ease of case. So let the standard parabola, if I take up any point which is outside the parabola, let us say x1, y1, and I want to draw tangents to this parabola at 2 points P and Q, and let us say this R. So these are the pair of tangents. So PQ and PR are the pair of tangents, right? Now if I want to write the combined equation of the pair of tangent for this particular curve, I can easily do it by, so let us assume any point on the tangent as h comma k, right? So this particular point, so if I try to find out the locus of this point t, then I am going to easily get the equation of the tangent, right? So that will be x minus x1 is equals to k minus y1 divided by h minus x1 into x minus x1. Okay, so this is how I can write down the equation of the tangent pt. So equation of tangent pt, right? Okay, now in the similar manner, if I just again simplify this part out, what I can write it as, so I can write this y is equals to k minus y1 upon x minus x1 x plus hy1 minus kx1 divided by h minus x1. Okay, so this is how I'm going to get it, right? Now if you compare that for a given parabola, so for a given parabola, when we had the line equation as y is equal to mx plus c, to a given parabola y square is equal to 4ax, right? Y square is equal to 4ax. We saw that in case of tangent, in the tangent case, the slope of the tangent was given as a upon c. The slope of the tangent was given as a upon c, right? So therefore, if I just compare from these two lines, so this is also the equation of tangent. Therefore, k minus y1 divided by h minus, so sorry, it should be h, right? H minus x1 should be equals to a upon c, right? And oh sorry, the c I can also replace. So let me write down the c over here, and c also I can replace with this particular part expression. So this c over here, because this is a c part, so this expression will become hy1 minus kx1 divided by h minus x1. Okay, so this is the expression for c and this is the expression for slope, and that should be equal to a, right? So if I simplify this part out, what I'm going to get is that I'm going to get k minus y1 multiplied with h y1 minus kx1, that should turn out to be a times of h minus x1 whole square, h minus h1 whole square, sorry, x1 whole square, right? Now what we try to understand is that now in order to write down the pair of tangent equation, what I'm going to write is the locus of this point t. So the locus of this point t is going to be the pair of tangent, right? Is the combined equation of the pair of tangent. So locus of t, which is given as h comma k, is basically the equation of pair of tangent, right? So this is the equation of pair of tangent, which I can simplify, and it will become y minus y1 into xy1 minus x1y is equals to a times of x minus x1 whole square, right? Which is again can be simplified further. So if I multiply and then simplify, I'll get the equation as y square minus 4x multiplied with y1 square minus 4x1 is equals to yy1 is equals to yy1 minus 2a times of x plus x1 and whole square of it. So therefore I'll get the expression as ss1 is equals to t square. So I will get the expression which is very similar to that of the circle. So we have seen that in case of pair of straight line, we described that this is the s equation and this is the s1 equation, this is the t equals to 0 expression, right? So s into s1 equals to t square, which is a very well known relation that we have established previously in our topics of circles. So in case of parabola as well, this particular relation actually holds true. So this is the combined equation of the pair of tangents from an external point to a parabola. I hope this is clear to all of you. Is this part clear? रश्मि प्रिया कॉम्प्लेक्स नंबर पढ़ाओ. मैं कॉम्प्लेक्स नंबर पढ़ाऊंगा बाद में, अभी तो कोऑर्डिनेट ज्योमेट्री कर रहे हैं ना, पहले इसको खत्म कर लेते हैं, ठीक है, फिर हम कॉम्प्लेक्स नंबर पे आएंगे ना. और अगर आपको अभी पढ़ना है तो जाओ, आप पुराने लेक्चर्स देख सकते हो, लास्ट ईयर में मैंने ऑलरेडी पढ़ा रखा है, ठीक है, एक बार पुराने लेक्चर्स देख लो. इज इट क्लियर? Is it clear to all of you? So let us discuss or start to discuss about some problems. Okay. So let us solve some problems to understand whatever we have studied. So here we go with our first problem on tangents. Okay. So this is my first question. So it is said that if the given line y is equal to 3x plus c touches the parabola, which is the standard parabola, okay, at point P, then find the equation of tangent at Q, where PQ is a focal chord, right? So it is basically simple calculation you have to perform yourself, because you know that how to find out the two extremities of the focal chord, right? So try to solve this problem and do let me know whatever answer you're getting. So try to solve this problem. Try to solve this problem first of all. All of you, please try to solve this problem. Okay. So the parabola is given as like this, where the focus is at 3, 0. So if I take up any point P and the focal chord will be something like this. So if the tangent at point P is given like y is equal to 3x plus c, so from here I can easily obtain that slope of the tangent, right? So slope of the tangent, and from there the point of contact of the tangent is given as am square comma 2a by m, right? So a by m square comma 2a by m, right? So this is how the point of contact of the tangent to a parabola looks like. Now if I want to write down the, so let us say this is basically given in terms of parameter t, where I have the parameter as 1 upon m, and that is basically 1 upon 3. Now if my parameter p represented by the parameter t, then the point q, which is the focal chord, so pq is a focal chord, so the other extreme of the focal chord can be given as minus of 1 upon t, right? So which will become minus of 3. So for q, the value of this parameter t is going to be minus of 3. Therefore the point q can be also given as 3 into 3 square, because a is equal to 3, minus 2 into 3 into 3, right? So this will come out to be 27 comma minus of 18. Okay, so 27 comma minus of 18 is the coordinate of point Q. So from this point coordinate of point Q, and also once we know the parameter 1 upon t is equal to this, therefore the slope of the tangent at Q, the slope of the tangent at Q is going to be minus of 3, right? The slope of the tangent at Q is going to be minus of 3, because sorry, minus of 1 upon 3, right? Minus of 1 upon 3, that is going to be the slope of the tangent at Q, right? And from there I can easily obtain the equation of the tangent at point Q, which will be given as y into minus of 3 is equals to x plus 3 into minus of 3 whole square, right? So this will turn out to be x plus 3y is equals to 27. So this will turn out to be x plus 3y is equals to 27. Okay, I hope this is clear to all of you. Are you all able to get to this answer? Is this part clear? Is this part clear? So let us try to solve another very interesting problem, especially very useful for your JEE Mains examination, is the equation of the common tangent, right? So here is a problem on equation of the common tangent. So you have to find out the equation of the common tangent to these two parabolas, right? So for the first parabola, the axis is the x-axis, and the second parabola, the axis is the y-axis, right? So depending on the two different parabolas, you have to find out that what is going to be the equation of the common tangent, right? So if you remember, in circles also we have discussed with the equation of common tangent, and similarly we are going to do the same thing for the case of parabola. So for the first parabola, it is a standard parabola like this, and the second parabola is something like this. Okay, so where this intersection point is going to be 1, 0. So this intersection point is going to be 1, 1, right? 1, 1 over here. All right. So the equation of the common tangent is going to be like this. So common tangent is like this, right? So this is the equation of the common tangent. Okay. So this is going to be the equation of the common tangent, right? So please try to just don't judge the diagram over here because I have drawn free-handed, but it would be like this, and we will have like this curve. So it should be something like this. Okay, this is the common tangent. So you have to find out the equation of the common tangent, right? Now how to find out the equation of the common tangent is a very simple exercise. Is that you try to find out the equation of the tangent to the first parabola. Let us say this parabola is basically given as y square is equal to 4ax. So to this parabola, try to find out the equation of the slope in the equation of tangent in the slope form, and then you try to satisfy this particular tangent condition with this particular parabola to get the tangent condition, and from there you can obtain the relation for the common tangent, right? So from there you can get the parameter of the value m. All right, so I would request all of you to please try this problem. Okay, at least try to solve this problem, and if you're unable to solve it, we can definitely sit and discuss about this particular problem, right? But please make sure that you are able to try to solve this problem, okay? Because these kinds of problems are very, very useful and very important, especially for your upcoming JEE mains examination. All right, so with this part I would conclude the session over here, and I hope to see your answers in the next class. Okay, so with this I wish you all the best.